that we will call it as first line and second line also. So let us come back to the main program. So you can see here 38 I used for 2 lines, display on cursor blinking, display clear display screen, and then shift cursor to the right side. And then I used 86. Just now I told you 80 is the command to display data into the first line. So but I used 86. That means I am moving towards right side 7-bit positions, and then there I am displaying data. That means in the middle, somewhere in the middle, we will get Y started. YouTube will start from that place. So instead of starting at 80, I started at 86. So after issuing that command, you see I am using data, LCD data. I am telling to display Y character. Command is at which place you have to display. This is the character, LCD data. So I like that I give all of the characters Y, O, U, T, U, B, E. Now I want to move to the second line. So I give LCD command 0xC6. Then I displayed HANU7. So for every character, like for H and A, in between we are using some delay. So we have to issue some, we have to give some delay between the transition of the different values which we are sending to the data. Similarly for commands also. So like that we can work with some commands. We can issue some commands. We can configure our LCD first. What are the things you want, and then issue the command in the first row or second row, and then send data. Now coming back to the 3 subroutines which I said in the beginning. LCD command is the first subroutine. So in this subroutine we will configure our LCD to enter into the command mode. So for that what I am doing is I am using port 2. Yesterday in the diagram we have seen port 2 is connected to data pins. So port 2 is connected to value. LCD command in this subroutine, you can see port 2 is equal to value. Value is nothing but whatever the command we are sending there, like 0x38, 886, C6, like that. Then RS I made it to 0, so it will enter into the command mode. Then we will make RW equal to 0. Then we will make enable equal to 1 for some time. Immediately we will make it 0. Then we will return to the main program. That is, after issuing first command, then it will come to this subroutine. It will do all these settings. It will go back to the main program. And then similarly for data, whatever the value we are giving there, like Y, O, U, T, U, B, E, HANU7. So that value is again sent to the data pins D0 to D7 through port P2. Then here we are configuring LCD in data mode or display mode. Then same step, RW equal to 0, enable equal to 1 for some time, and we will make it to 0, and we will go back to the main program again. And the delay which we are using in the main program, the delay I have generated using for loops like this. So this is how we will write a program for LCD. So after that I compile your program. So I got 0 errors, 0 warnings. So I would like to develop a executable file. So executable file I am giving here, HANU7. These all steps are explained in that video, how to work with kill. So I suggest viewers to go through that video. So again let me compile. So I got executable file HANU7. So let me minimize this and let us go to the simulator Proteus. So in this Proteus software, whatever the diagram we have drawn yesterday, that we can construct, and then we can see the simulation part. I hope, let me click it again. Yeah, it is opening. So I already created a project to save the time. So let me open that project. these simulation softwares and the one which I am using to record the screen all requires more good hardware configuration. So in my laptop I have only 2 GB RAM, so it is taking time to open the project. File, open project. So this is the diagram which we have seen yesterday. So we took microcontroller 8051 and we connected all the data pins D0 to D7. D0 to D7 are connected to port 2, and then this RS is connected to 1.1. I think this is not correct, so we have to change it to 1.1. These 3 connections I will do it now. So RS is connected, according to our program, RS is connected to P 1.0, and then R second one, that is read write, is connected to P 1.1, and then enable is connected to P 1.2. So yesterday I said we will use a port, 10K port. To that port 3 terminals will be there. So this is the terminal where we are connecting it to VEE, and one terminal will connect it to VSS, other terminal will connect it to VDD. And this one can be varied while in the simulation. I will show you. You can see here the resistance value can be varied. So accordingly, you can get the brightness and contrast in the original hardware, not in the simulation. So let me start. But before starting the simulation, let us see how to dump the code. Our file was HANU7 HEX file, which I have generated using the key. You can see here HEX file is created with name HANU7. So that file I am taking and dumping into the microcontroller's memory. So select that file and then open it and then click OK. Now if I run the simulation part, so because we programmed our controller to display message YouTube, so you can see here YOU. I will show it bigger. Again, because it is in while one loop, it will continue. So instead of starting at line number 1, at first position in the row 1, here cursor is going to the 7th position, 0 to 6. Then it is displaying characters there, YouTube, and again C6 HANU7. So like this we can program the controller 8051, and we can set our LCD in display mode or data mode and command modes, and we can show some output onto the LCD. We can display some data onto the LCD. Thank you.